Hey everybody. Today we're talking about straight lines and point slope form. So remember that the slope of a straight line measures how fast it's increasing or decreasing as you read from left to right. Lines with positive slope slant upward, and lines with negative slope slant downward. Horizontal lines have zero slope, and vertical lines have undefined slope. It's traditional to use the letter m to represent slope, and it's calculated by taking the difference in the y values from any 2 points on that line divided by the difference in the x values for those same 2 points. For shorthand, we say it's rise over run. I think this all gets clearer when we have an example with a picture, so let's get one of those right off the bat. Here I've drawn a line and labeled 2 points on it, 1, 3 and 7, 1. The rise is going to be the difference between those y values, and the run is going to be the difference between those x values. Here, subtracting the two y values starting with 3, I get 3 minus 1, or 2. And subtracting the x values starting with 1, I get 1 minus 7, or negative 6. Simplifying that a little bit, negative 1/3. I would have gotten the same value if I had chosen any 2 points on this line. For example, 4, 2 and 7, 1, instead of 1, 3 and 7, 1. However, it's important that you maintain the same order when you do the subtraction of the y values and the x values. Here's an important interpretation of slope. If you have a line with slope m, then moving 1 unit to the right along the line is going to require you to move up or down by m units. Up if m is positive, and down if m is negative. For example, this line has slope negative 1/3 and passes through the point 1, 3. If I move 1 unit to the right from x equals 1, I have to go down by 1/3 of a unit. So this line must pass through the point 3, 2 and 2/3. Going 1 more unit to the right, I get to the point 3, 2 and 1/3. To the right 1, and down 1/3. Parallel lines have the same slope, as illustrated by this picture. Here's a bunch of lines that all have slope 2. Going 1 to the right takes you up 2 along any of these lines. So specifying a slope does not uniquely identify a line. To fully identify a line, we need both a slope and a point that lies on that line. This leads us to the point slope form for the equation of a straight line. Y minus y1 equals m times x minus x1. Here m is the slope, and x1, y1 is any point that lies on the line. This is a very important formula. It's also, fortunately, one that's fairly easy to remember, because if we divide both sides by x minus x1, we just get the formula for the slope of a line in a certain form. M equals y minus y1 over x minus x1. Let's see an example of how we might use this formula. Find the equation of the line passing through 9, 2 with slope 1/3. So I want to do y minus y1 equals m times x minus x1, where x1 is 9, y1 is 2, and m is 1/3. Here's what I get. Y minus 2 equals 1/3 times the quantity x minus 9. I can simplify this a little bit by foiling on the right and then adding 2 to both sides to get y equals 1/3 x minus 1. Here's an illustration. You can see the slope of 1/3. Every time I go over 3, I go up 1. And you can see that it passes through the point 9, 2. Here's a slightly different example. Find the equation of the line passing through the points negative 3, 5 and 4, negative 2. Here, instead of being given a point and a slope, I'm given 2 points. So the first thing I should do is to compute the slope by doing rise over run. In this case, I'm doing negative 2 minus 5 over 4 minus negative 1/3. All of that simplifies to give me m equals negative 1. Now I can do point slope form, y minus y1 equals m times x minus x1. Using m equals negative 1 and either one of those points, I should get the same answer regardless of which point I use, at least after I simplify things. Using negative 3 comma 5, I get y minus 5 equals negative 1 times x plus 3, or y equals negative x plus 2. By the way, we can check our work here by plugging either one of those points that we were given into this equation. For example, when x is 4, I'm getting y is negative 4 plus 2, y is negative 2. So in fact, the point 4 comma 2 does satisfy this equation. You should also check that negative 3 comma 5 satisfies this equation. I won't talk through that right now. Here's another example. Find the equation of this line. So we're going to pick 2 points on the line. There's many choices. I'll use 0 comma 4 and 6 comma 0. And then we're going to compute the slope. Once we have the slope, we'll use point slope form using any one of those points that we can identify on this line. Here, the rise is negative 4 and the run is 6. So the slope is going to be negative 2/3. I'll use point slope form using the point 0 comma 4. Y minus 4 equals negative 2/3 times x minus 0, or y equals negative 2/3 x plus 4.